So now we will see the demonstration of testing of MCB. So here we have one pole or single pole MCB is given to us for testing purpose. So this is B16 type MCB. Here you can see. So it is a type B MCB and 16 ampere denotes its rating. So rated current of the MCB is 16 ampere. Then again rated voltage, here it is written 240 volt. The rated voltage is 240 volt oblique 415 volt, and below that one figure is there, that is 6000 ampere. So that 6000 ampere is the breaking capacity of the MCB, and Legrand is the manufacturer of this particular MCB. So for testing purpose, the two terminals of the MCB I have connected to a cable, and this cable I have connected here between common and 50 ampere. So you know these are the tappings of our current source. So this is common, this is 50 ampere, this yellow one is 100 ampere and red one is 150 ampere. So we are using 50, 100, 150 ampere current source. Out of that, presently I am using a tap of common and 50 ampere, right? So this external NC is shorted so that current will be injected through the MCB. Then this ASS I have chosen to 50 ampere because I have chosen 50 ampere tap. So ASS is also 50, CSS is also 50, right? And now I will switch on the main supply. These RYBN wires from the table are connected to RYBN of the switchgear testing kit, as we have seen in the demonstration yesterday. So I will switch on the supply. So supply is switched on. Now I will switch on the MCB, second step. So MCB is switched on. So supply reached to the kit. Here you can see some of the meters are glowing. So supply reached to the kit. Now I will start the current source. Now as soon as I start the current source, I will start the timer also, because I have to measure the tripping time of the device. So I will start the timer also. So timer will give me the tripping time of the device. For testing this one single pole MCB, first as per the procedure, we have to pass multiple of set currents or multiple of rated currents. So rated current is 16 ampere. So we can pass 2 times of this, that is 32 ampere we can pass and measure the tripping time. Then we will pass 2.5 times, that is 40 ampere, and then measure the tripping time. And finally we will pass 3 times, that is 48 ampere through the MCB and measure the tripping time of the MCB, right? So I will switch on the current source now. I will switch on the current source, and now I will inject the current through the MCB. See now this current I have injected 11, 20. How much current I want to inject? 32 ampere. So I will set this to 32 ampere. So you can see now I have set it to 32 ampere and I have started the timer. My timer is started. Okay, so see here 32 ampere and this one timer is started and this MCB is in a closed position. So after some time this MCB will trip. Now as soon as MCB will trip, I have to stop this timer and current automatically gets 0. Current automatically will be 0. So let us observe these two. So see, MCB is tripped and here the timing I got 24.15 second. Okay, and here current getting 0. Okay, so I have to stop this now. Okay, so this is our first reading. Okay, now we will wait for here I will write down this in the observation table. I will write down this timing 24.15 second in the observation table for 32 ampere. And now in order to get second reading, we will wait for 5 minutes, because this bimetal strip get heated. So it has to be cooled down. Otherwise we will get the wrong reading. So we will wait for 5 minutes and then we will take the second reading. Okay. Now we will take the second reading. Now for second reading we have to pass 2.5 times of rated current, that is 40 amperes we have to pass, and again we have to note down the tripping time of the MCB, right? So I will switch on this current source again. See, MCB is in a closed position. MCB is in a closed position. Timer is 00 right now. Once I pass the current, then once I pass the current, then will measure the tripping time of the device. We'll start the timer and then see. I will switch on the current source. See, I am increasing the current. How much current I have to pass? I have to pass 40 ampere. So I will set it to 40 ampere. See, it is now 40 ampere, and I will start the timer. Timer is switched on. This is almost 40 ampere. 39.5, that is almost approaching 40 ampere. MCB is in close position. It is tripped. So MCB is tripped. Okay. See how much time? 8.89 second. So after 8.89 second, MCB is tripped. Okay. So I will switch off this source, and that is how our second reading. So I will write down here this how much current I got, 8.89. This is my second reading. Okay. Now for third reading, we will wait for again 5 minutes, and after that we will pass how much current? 3 times of the rated, that is 48 ampere will pass, and again we can measure the tripping time. Okay. 48 ampere of current for the third reading, and take down the tripping time, how much time required for the MCB to trip. Okay. So I will switch on this current source and see how much time I am going to adjust. I am going to adjust 48 ampere. See, 48 ampere I have adjusted, and I have started the timer. See here, 48 ampere. You can see on the screen. See, MCB is stripped, and see how much time it has taken. It has taken 6.01 second, and the current is again interrupted, that is 0. Okay. So here I will write down for 48 ampere. It has given 6.01 second. So from this, what we conclude? We conclude that as the current go on increasing, the tripping time of the MCB go on decreasing, and therefore when you plot the characteristic current versus time, current is on x-axis and time is on y-axis, then it will be inverse one, just like this. So you have to plot these 3 points and join these 3 points by smooth curve, so that you will get the inverse characteristic current versus time for our MCB. And if you plot here one tangent parallel to time axis and one tangent parallel to current axis, respectively, you will get here, you will get the pickup current, and on y-axis intercept here you will get saturation time. Okay. So that is the information we are getting from this experiment, right? In the ideal condition, you will get this pickup current, that is nothing but equal to the rated current of the MCB, that is you should get 16 ampere. But at present, since we have done it in the laboratory and we have not done it under standard condition, therefore we may not get this pickup exactly at 16 ampere. But in the journal, you just write down the tangents which are cutting to the current axis, that gives you pickup current, and the tangent which is cutting to the y-axis, that gives you saturation time. Okay. So this is the observation table, right? So thank you very much. Thank you.